guys? Can I hear it once again? Hi. Good afternoon, everyone. I hope you are enjoying the event so far. So we are excited to kick off our next session of the day, a session with a workshop on GitHub Copilot. We are privileged to have Ms. Umarani T. Garu with us. I hope you are enjoying the event so far. Voice నాకు నాదే
Why are you watching the live? Ma'am, 1 minute.
We can start your session, yes. Connect
PPT. They didn't give us PPT.
Not PPT. It's like from ma'am's laptop.
Laptop. Exam answer. HDMI disconnect చేయవా? సరే. అది బెటర్ ఇది బెటర్. ఇది తీసి ఇంకోటి పెట్టు. మీకు కారణం కావాలా మీకు?
Anything is okay. Which one to click?
USB is not there, madam.
USB ఉండదు దీనికి.
అది యాక్చువల్గా మ్యాక్కి అది పెట్టారు ఇంకో అడాప్టర్ పెట్టారు
ఒకటి ఉంది ఒక పోర్ట్ ఉంది పెట్టి ఇది తీసేద్దాం అడ్డుగా ఉంది.
చెక్ చేసుకోండి మేడం ఒకసారి.
Yeah, I think everyone has seen my message. There's a contest already running on. You need to tag about the event overview. Please complete it by 3 o'clock. Each and everyone has to participate in that. Do it fast.
ఇది తీసేద్దాం. Hello everyone. Am I audible? Okay. Hope you all had a good lunch. So generally, when I have to attend a session after lunch, it's very challenging for me because we feel so sleepy. So now today I've been given this chance to speak just after the lunch. So I'll have an extra responsibility to ensure that no one feels sleepy. So let's begin today's session. So my name is Uma Rani. I am a developer productivity global black belt at Microsoft. And I'm very excited to talk today about this fascinating tool, which is GitHub Copilot. So how many of you know about GitHub Copilot here? Anyone knows? I see a couple of hands raised. Okay, good. So today I'll be giving you a little bit overview of what is GitHub Copilot, how it works, some real world use cases, and some tips and techniques that will help you to use GitHub Copilot more effectively. So now everyone knows about Gen AI, right? Gen AI is, everyone is speaking about Gen AI. So what is Gen AI? It is not just a buzzword. It is it's like a transformative force which is reshaping the way we work or reshaping the way we live. So think about the recommendation algorithms which Netflix uses. I mean, it suggests us what next I would like to watch based upon my previous content that I have seen. Similarly, even in customer support area, a lot of the repetitive discussions or repetitive questions are answered by the AI bots. And only complex problems are being dealt by humans. So these AI-driven tools are enhancing our personal productivity and our entertainment experiences. So as we move forward, the influence of AI will continue to grow, and it will make it essential area of focus for anyone who needs to stay ahead in this fast-paced life, right? So as we look into the future, the role of developers is evolving. The next generation developers will not only use AI to build applications, but they will also integrate AI directly into the applications. So when I say build using AI, I mean leveraging tools and technologies to develop applications, like using tools like GitHub Copilot. Or, I mean, so when we say GitHub Copilot, it's like a coding assistant tool. So it will enhance your development journey. And it can help you in providing code suggestions. It can automate your repetitive tasks that you do as a developer. And when I say build AI into apps, what I mean is when you develop applications, you will also integrate AI capabilities into your application as and when you build it. So like this could involve adding features like natural language processing or image recognition, and also things like predictive analytics to your applications. Now, as the landscape of software development is evolving, the expectations placed on developers is also changing. So now, by leveraging tools like GitHub Copilot, the development process is more easier. And I mean, you are expected to be more innovative, develop applications faster, and deploy using responsible AI. So when I say responsible AI, you need to ensure that the systems that you build, they perform well as it follows the ethical standards. So this is what is expected from developers as a part of developer productivity improvement. Now, GitHub Copilot is about helping developers translate your thoughts, your ideas as fast as possible. So back then when I was a developer, we didn't have these tools, so it took a lot of time to implement any project or any application from requirement stage to development stage, then testing, and then finally going to production. But now with the tools, with AI tools, helping the developers into their developer journey, it takes very less time to develop applications and bring ideas to production as early as possible, right? Now, what is GitHub Copilot? Little bit of theory here. So it's an AI pair programmer that helps you write code faster with less work. So it's a coding assistant tool developed by GitHub in collaboration with Microsoft and OpenAI. And the term AI pair programmer or copilot are important here because this tool cannot work without you, the developers. So it's just an assistant. It's not that we are saying we don't need developers anymore. It is just enhancing your developer journey or your coding experience. So GitHub Copilot uses natural language processing to understand the context. And it is trained on billions of code repositories that are available in GitHub. It generates code suggestions in real time. And it can be integrated with a lot of popular integrated development environments, which we call as IDEs. Now, if you see here, in this is a developer journey. Consider it as a developer journey. So you, the developer, is the pilot, and you have the full control of the plane. And the person sitting right next to you is the co-pilot, who is just assisting you in your coding journey. So the goal of GitHub Copilot is not to replace the developer, but to assist you and make your life easier. So you still need to understand all your basics, all your OOPS concepts, all the fundamentals, and then it can help you to improve your development process. Because ultimately, whatever it code generates or whatever help it gives, you need to validate it. You need to decide whether it is appropriate for my work or not. So you are the hero of your coding journey. So what is required to use GitHub Copilot? You need to have a GitHub account, you need to have a Copilot license, and you need to have a supported IDE. And what IDEs are supported by GitHub Copilot? You can use it in Visual Studio Code, JetBrains, NeoVim, and Azure Data Studio. So each IDE has different interfaces. So you might see different types of way you will be using GitHub Copilot. But eventually, all these IDs will help you to generate code, to get code explanations, and a lot of other features are there which I'll cover. So these are the IDs wherein you can use GitHub Copilot. Now let's see how behind the scenes it all happens. So on the right side, you see that is your IDE at the extreme right, wherein you write your code in any of the programming languages. So there you have to install GitHub Copilot extension. And once you install the extensions, you will get a chat interface in your IDE. And as in when you type, it will collect the context from the file where you are typing and from the neighboring tabs that you have opened. And it will collect that context. And then it goes to from your IDE, it goes to a proxy server. There some kind of filtering happens, like it checks whether there are any hate speech or some kind of a violence content, any abusive languages. And then when it passes it first authenticates and then checks all this. And then once it passes that filtering, it goes to the OpenAI models, LLM model, where it generates the code as per the instructions, as per the context that it got from you. And then it discards all the content that it collected, and it just sends the code which it generated back to the IDE. And again, in between, the proxy service will filter the code that it generated. It will again check whether the code is following the quality standards, if there are any security issues in the code. And there is an optional duplicate detection filter wherein it also checks if the code that it generated matches public code as is. So up to 150 character code check it does. And if it matches public code, just to avoid plagiarism, it will reject that and it will not give to the user. So in case if it passes, all these security checks are passed, then the code is finally sent to the IDE. And all this happens in just a few seconds. You will not even notice that behind the scenes so much of things have happened. So again, after the checks are cleared, the suggestions are sent back to the IDE. So how Copilot Chat can help you? In what areas you can leverage Copilot Chat or Copilot as such? So you can learn new languages. So suppose you are all new, right? So you new languages you'll have to learn based upon your curriculum or project works that you do. So you can leverage GitHub Copilot to learn new languages. You can use it to understand some of the best practices. So you might be knowing C, C++, Java, something, but you might not know what are the different ways of writing a particular logic, or what are the new frameworks that are available that I can use. So you can interact with GitHub Copilot and ask questions on best practices. You can give us a problem to GitHub Copilot and ask it to help you in implementing that particular scenario. If you have an existing code that you might have taken from some friend or from GitHub, and you want to understand how it was implemented, so you can ask Copilot to explain the code. It will help you line by line what that code does. It can also give you multiple solutions to a problem, and you can select which solution you want to accept. And experimentation. So as a student, you might have to do a lot of prototypes, you might have a lot of ideas, and you develop lots of apps. So you can do experimentation, develop quick prototypes using GitHub Copilot. So like I said, it is a supplement, not a substitute. Remember that is the most important thing. So students or all the, whoever is trying to start their software developer journey, so they should understand that you should not use Copilot as a supplement to your learning. It's not a you should use Copilot as a supplement to your learning. It is not a substitute. And you should still engage in your traditional learning methodology, like reading documentation, taking courses, and practicing without assistance. So that is still required, but just use it as a supplement. So what are the different plans of using GitHub Copilot? So we have GitHub Copilot Individual, GitHub Copilot Business, and GitHub Copilot Enterprise. So GitHub Copilot Individual, anyone can use as an individual. You can just, first you can start with a trial license, a 30 days trial you can get, and then you can explore how it helps, and then you can purchase it. Then we have GitHub Copilot Business. It is available for organizations with a GitHub free or GitHub team plan. And then we have GitHub Enterprise, where GitHub Copilot Enterprise is available for organizations who are already using GitHub Enterprise platform. So now let's see some of the demos of how you can use GitHub Copilot. So let's see first how you can use GitHub Copilot to how you can use comments to write code using GitHub Copilot. So here I am in my Visual Studio Code, and I have a sample Python application already existing. So I'm giving a comment here, like I'm saying, create a function to plot the signals from the dataset. It's a application wherein some plotting things are happening. So I just pressed enter, and it generated the whole piece of code for me based upon the comment that I gave. So like this, you can give 1 or 2 line statement, or the more description you give in the comment, the more better result you will get. So this is how you can use Copilot to generate code from code comments. Now let's see how you can generate code with GitHub Copilot Chat. So here again, I'm in Visual Studio Code editor. And in the left side, I have a GitHub Copilot Chat open. The interface is open. And I have given a comment in the chat, generate code to get books by category ID. So I had a bookstore application code here in Java written. And once I pressed enter in the chat, it generated me the entire pseudocode and all the entire method with all the things that I needed. And it will, Copilot will check the existing code. It's my pattern, like what all things I'm using, my naming conventions, variable names, how I'm defining. And it will follow the same when it will generate code for me. So now let's see how you can use GitHub Copilot for code explanation. So again, I have a Python application, and I have been given a task of implementing some changes in this code. And first I need to understand what this code is all about, right? So I can select the code, and I can ask Copilot, can you explain the selected code? So it will analyze this code and explain me step by step what is each line doing, what are the functionality that has been implemented here. So this way you can, you don't need anyone to explain you, right? I mean, you can understand what code does on your own. So typically in companies, what happens, someone leaves the company or someone joins, or as a new, or the project is expanding and you are onboarded into the project. And everyone is busy. No one is having time to sit and explain you what this code is going to do. So you can leverage GitHub Copilot to understand the existing functionality and start contributing in this project as early as possible. Now, scaffold boilerplate code. So a lot of times when even when you have to do a project work or you want to develop some idea into a project, so you will have to start from scratch, right? Some project structure you will have to create base files, whatever is required, exception handling, logging, or some components. The basic template is required. So you can use Copilot to generate even the boilerplate code. So again, I am in Visual Studio Code, and I have given a command here @workspace/new in my chat, and I'm asking Copilot to scaffold the .NET Core Web API application for a project name. So I've given the entire requirement that I want to develop, and it has generated the entire folder structure and some basic files that I wanted that it should be there in that project. And then when I click on Create Workspace, it asks me to select the location where it can place all these files. So this way I don't need to waste my time in writing the basics which Copilot can help with. And from here I can start implementing the actual complex solutions into this existing template. Now, unit test is very important for a developer. So whenever you write a code, you need to ensure that you test your code. So manual testing is fine. I mean, you can just read line by line, but automated unit tests help you to, like for example, you have developed an application and you have written automated unit tests. So later on when the project is deployed to production and an issue comes and you have to fix you have to do a bug fix. You need to ensure that the fix that you are going to do now, it's not going to reproduce any other problem, or the existing functionality should not be broken, right? So these unit tests help you quickly validate a particular fix and ensure that, okay, my new change is not going to break my existing functionality. And this is something which is so important, and most of the time I have seen that developers don't write unit tests because it takes time. It is also like writing a code itself, right? You have to write code to test your code. So you can leverage GitHub Copilot even for writing your unit test. So let's see how it helps. So again, I have an existing code base and I want to write unit test for this particular application or particular method. So I can select the method, and again, there are multiple ways. So I can just right click on it. I have a Copilot option here. I can click on generate tests. So it has generated me the unit test. And I can also give more details like which unit test framework I want to use. Each technology has a specific framework and libraries. So that is one way. Or I can simply use the chat interface also. I can select the method and I can ask Copilot chat to generate the unit test for me. So I can also give more details in the prompt, like test all the positive, negative scenarios, or check not null scenario. So the more unit tests you write, the more confidence you'll have, okay, my code is perfect and it will not break in any circumstances. So it has generated the code, and I have also given that use NUnit framework. So more information you provide in your prompt, the better results and the more accurate results you'll get. You can also use GitHub Copilot to debug your terminal issues. So a lot of times you write code, and when you compile your application, you get a lot of red color errors in your terminal, right? And it is so sometimes frustrating to read those errors and understand and sometimes the fix could be very small, but the description will be very big. So again, you can leverage GitHub Copilot to fix your terminal issues as well. So I am here in my .NET application, and I am running some command. So you can see there are a lot of red lines in my code. So definitely this is not going to work. It will be giving me compile errors. So I now try to run, first I'm going to my folder, and then I'm trying to run .NET build. So obviously there are errors, so it will not compile, and I'll get a lot of errors. So there are so many errors. Now I can just select that error message, and I can ask Copilot to help me fix this error or suggest me what are the issues in this that it has listed down here. So I am selecting here the error message in the terminal. And I again have a lot of options to chat with Copilot. So I am asking Copilot to fix this error. And this time I'm going to select hash terminal selection. So then the context I'm giving is this terminal window. So again, it has identified the issue and it has given me that, okay, I have not included certain packages into my application. Because of that, the error was coming. So in this way, I can quickly fix this type of issues using GitHub Copilot. You can even chat in the terminal. So even in the not only in the left side of the ID, even in the chat also, you can just press Control-I in the terminal. You will get a small pop-up window. And you can communicate with Copilot, like again, how to install a NuGet package or how to install an NPM package. Based upon your technology stack, you can ask questions and it will give you with the commands that you can use. So these small things, generally you go out and you go to Stack Overflow or Google. So this will help you to stay in the flow. You don't need to go out of your ID. Within ID, you can leverage this tool and get help from it. So save time. You can save time in avoiding so much of deviation from your flow. You can also use GitHub Copilot in legacy code migration. So a lot of time, even my lot of organizations that I have seen, they have a lot of legacy applications like COBOL and few others. And all of them are now planning to migrate to modern languages, say Java. So in these scenarios as well, GitHub Copilot is quite helpful. So first thing is we need to understand what this program is all about. So you can just select. So here I am having a sample COBOL code. So I have selected the code and I'm asking Copilot to analyze and convert this code to Java. So it will help me first understand what this code is all about, and it will suggest me the possible ways of converting it into Java. Sorry? Okay. So I'll just skip few of the things because they are a little bit, okay, code review you can use for selecting a code and just ask it to review code and find issues in your code. And then you can use it for, you might have a coding guidelines document. So you can ask Copilot to review as per your coding guidelines document. You can create sequence flow diagrams using Copilot. So I have an existing code here and I'm asking Copilot to generate a sequence diagram for my method. So it will generate me a code, which is I have asked it to use Mermaid.js library. And I can simply use that code and go and paste it in Mermaid.js live editor and refresh it. So it will generate me the sequence diagram. So normally to create a sequence diagram, it takes a lot of time. You have to understand manually the flow and then create it. But using Copilot, it just took a few seconds to create a sequence diagram for your existing code. You can use it for code refactoring. You can use it for database queries. Now Copilot is multilingual. I mean, you can communicate with Copilot in most of the languages it understands. So like here I am communicating with it in Hindi. I just asked it, can you explain this code in Hindi language? And the words are, I mean, the letters are in English, but it is actually in Hindi. And then these are some good, bad. So it's all about prompting. Like the better prompt you give to Copilot, the better results you will get. So if you just ask, how do I style my button in case of any UI application, you might not get a good response. But if you ask Copilot with more information, like I need help styling my buttons using CSS, and I've given a lot of information here. So then you will get more good results from Copilot. And these are some techniques that you should follow when using GitHub Copilot. Have a high-level description, use examples in your prompt. Any relevant files that you want GitHub Copilot to keep in context, you keep those files open in your IDs. And if you don't get response in first attempt, iterate. So this is a main thing. And it is Copilot is probabilistic, not deterministic. So you might get different results different times based upon the context that you are giving to Copilot. And this is the blog that you can follow to know latest updates on Copilot features. So finally, Copilot is just like having a GPS for coding. it helps you to find the best route, but you still need to keep your hands on the wheel. Okay, so that's all from me. Any questions I can take?
Any questions? Yeah, actually, I saw someone raising their hand. Any questions? No. Thank you, ma'am, for this insightful workshop. Now we move on to our distinguished lecture. Okay, sorry.
Yeah, the question was about the output of Copilot is only text or code, or can we get other media output also from Copilot? That was the question.
It is GitHub Copilot is primarily for coding, but you can get architectural design patterns. You can communicate with on guidelines, best practices. So text also it will return related to coding or general architectural related content or discussions.
So maybe even some logic circuit.
Yes, yes, yes.
Thank you.
Thank you, ma'am. So we are honored to welcome Professor Swadesh D, a professor at the Department of Electrical Engineering at IIT Delhi. He will be presenting a talk on in-band coexistence in legacy communication bands and spectrum shared communication. Please give a warm welcome to Professor Swadesh D. Sir, do you want the connector?
There should be something, right? I need the HDMI.
Yeah.
Yeah, that should be fine. Yeah. Yeah, thank you. Okay, good afternoon. I'd like to thank the organizers for inviting me. So am I audible? Okay. So my presentation is going to be very different, possibly not much appealing for the students as such, because this is research-driven and research thought-driven. Ma'am's talk has been actually appealing in the sense that it helps you getting job, possibly for the job market. It's quite interesting that way. So, but let me see. So I would like you to maybe raise questions. I have actually two parts in my presentation. In the first part, not necessarily interesting for the students, but I would like to point to certain things which are in general we expect actually from students, from institute, from what are the. In fact, I was asked to give some overview of what are the challenges we face as academics for doing research and so on actually. So I wanted to go through these slides, and then I will come to a more specific topic of my research. Out of some of my topics I picked up in-band coexistence.
So in the first part, I'm going to actually talk about these. So I consider myself primarily a researcher and secondarily a teacher. So I say that okay, 60% of my effort goes in research, 30% goes in teaching, and 10% in my professional activities and so on actually. So and over the years, I am now reasonably senior. So if you have question, please raise. If you do not have question, please keep quiet. Okay, don't chat with each other. If you have any question, I'd be happy to take the question and move forward. All right. So, I am going to discuss something about what are the challenges I faced over the years, and as senior professor now, what I think we should do. I wanted to give some overview on that actually. So, quite dense slide actually. So, in general, we publish a lot of good papers in the from the institutes. We have pointer doesn't work. This way. Pointer does not point. Okay, it does not point here. Okay. Okay. So we have we publish. But most of the times what happens is our publication actually don't translate to products. Okay, that is in general as Indian researchers. I have been in IIT Delhi for last 17 years now, 18 years now actually. So what I am interested, I actually after my undergraduation, I spent a few years in industry. And so I was in R&D, and then after that I felt I would like to do some more advanced research. So I went to masters and PhD, and then I came back. So I have an interest that okay, whatever we do should be technologically relevant, and also even if it is technologically relevant, what are the challenges we still face that obstacles which actually do not allow us to move forward actually. So as I mentioned, majority of the technology translation in communication and societal contribution through communication technology development has good scope of improvement. This is actually a light way of saying actually. What I mean is that our research have rather little societal impact from Indian context. Why? The reason is primarily because in communications area particularly, R&D is very, very minimal, unfortunately. We actually, most of the communication service providers are actually buying equipments and installing and then providing service and earning money. So unfortunately, we do not have our own R&D units, R&D companies who are developing in-house actually. Our students go to these different companies. Actually, they are doing something, but what happens is that the students are given problems to work on black boxes. You do not know what is going to be done with your developed unit. You are given some input, and you are supposed to make some output, and you say that okay, I have done this thing. And with that, there is a big puzzle going to be solved, and that big puzzle is not going to be told you actually. Okay, so and that is because most of the companies that our students eventually work in India are actually multinationals. Multinationals have no interest in Indian growth as such. They are interested in making money over here. I am being very frank, and so they want to actually, of course, make use of our good mind. A lot of good minds around. So that is fine actually, a business strategy. So basically, example is that in IIT Delhi, Ericsson was invited to set up a 5G system. Expectation was that it will help us to develop 5G system. But to start with, they actually did not allow us to touch the internals. What that means is that if I have a, let's say, system algorithm I have developed, can I test this algorithm by incorporating in their system? No. They say, no, there is no way, because there are a lot of IPs involved, we will not give you the internal access. So it does not help actually. So this is what that means is that this is not helpful actually. Airtel also came forward saying that okay, we want to install a 5G system. Actually, Airtel actually bought a service the equipment providers the 5G system, Huawei in this case. Again, Huawei came, installed, and next 3 years no one could touch the system actually. Not their engineers were present there for helping explaining what is problem, etc. So it is actually not helpful. So what I am trying to come to is that we on the other hand, because of this development is not happening, we are publishing as islands of, let's say, communication researchers. Publications possibly are benefiting maybe the companies, international companies who are able to extract the content and then not helping us within India actually. So in fact, from my own experience, when I came back from, I was in US as a faculty, I actually was doing more theoretical experimental research. When I came here, I realized that actually doing experimental research is very challenging. Challenges are multifold actually. One challenge is that purchase process, extremely difficult. And then I have to write project to get this the experimental setup. Project management is another huge challenge actually. So finance management. So finance management, I as a professor do not want to deal with finance related queries from the funding agency. We have to actually deal with, unfortunately. And so, for example, I had a student, PhD student, who I had a collaboration with some Ireland university. The student went there, and in 7 days, she was able to start an experiment from the definition to the experimental hardware, and in 7 days he started the experiment. Next 2.5 months he spent, he got some good result. So I thought we have a lot of interest in this direction. Let me procure similar setup and then start doing something. It took me 6 months to find out how to get these components actually. In fact, by the time student was graduating, so I could not actually make use of the purchase that we did by the time we did, student graduated actually. So these are the struggles actually. So these are all intertwined actually. So I mentioned lack of cutting edge experimental system research facility and engineering implementation support. There are two questions. One is, you see, the communication systems is a very complex system. I hope there are students who are doing EC, BTech, MTech, and PhDs. How many BTechs who are doing EC? Okay. How many masters students doing EC? Masters, none? Okay. How many PhDs who are doing communications? Okay, good. Any more communications PhDs? So the trouble is that our so in communications area, developing things and developing algorithms and implementing algorithms are actually require very different skill set actually. So making algorithms or developing a proof of concept, it requires a lot of theoretical depth actually. Optimization theory, communication theory, probability theory, Markov processes, and game theory, and so on. They themselves are quite hard to master, and the same person is not expected to gain skills in FPGA coding, for example. So as a result, the researcher and developer are two different the verticals actually. We need a set of researchers who will develop these proof of concepts, MATLAB-based verification, maybe some NS-based verification, but we cannot expect that the same person is also going to develop this FPGA coding and to actually see that it is going to work actually. So this is another challenge actually, because we interact with each other. You see, the communication implementation, who are doing implementation? VLSI people, computer technology people, computer engineering people, not communication people actually. So what that means is that we need to have cross-disciplinary interaction, which does not happen much. That is because we do not have the system research facility. System research facility is not we don't have, because it is very difficult to set up the facility. More importantly, it is very difficult to manage the facility. So today, let's say with a lot of effort, I make a facility, and then After this facility is done, the people, let's say some students help, I get the facility, student graduates, then who will maintain the facility? Who will upgrade the facility actually? Because the communication system is upgrading with time. Every 2-3 years, you see that whatever you have, this setup possibly need to be upgraded actually. So what that means is that we need experienced engineering hands who need to be supported with sufficient industry grade salary and stable job position, so that they can actually be retained and they can actually do things. So this possibly for the students it is little difficult to comprehend, but I hope this message goes in some sense. So, and also what happens is that because we do not have systems research as such, I, as a senior professor now, I see that our communication labs are actually obsolete. That is because we are not upgrading, because we are not seeing what is actually happening in the fine front-end industry actually. So so now the question is that if we invert the problem, if we have the system research capability, if we somehow can maintain these engineers who can do these implementations for us, then possibly this can actually spawn this direction of developing labs which are modern, cutting edge, and these are going to be updated and upgraded continually. So this is what we are actually interested. So what we are looking at is so this Center for Excellence, many senior professors are here, are quite familiar with this term, Center for Excellence. In fact, in India, there are a lot of Center for Excellence being developed today, actually. But what I mean is that in our context, again, in communication context, that we need to, so what are the reasons here? Faculty research translation from research to technology prototype, facilitation to technology incubation, meaning that if I have this kind of research center for excellence, this could help this thing. Externally funded joint academia industry R&D project execution, that could help us in terms of self-reliance and test facilitation and communication R&D company. So let me go through a little bit more further. So now from the, I'll come back to these details a little bit more. So what we should have, again, from my perspective, is that MTech, PhD, MSR students should have more industry internship opportunity. So why I am emphasizing, of course, BTech students go for internship, right? You have to possibly go at the end of third year. But our problem is that internship definition is done by the industry, has no connect with what professors would like. It does not work actually, because in most of the cases, the students go for internship, pick up some industry problem which is possibly very disconnected from what you are supposed to do. For example, if you are a ECE student, you should do internship in the ECE direction possibly, ECE to computer technology, fine. And also, most importantly, these internship problems should be connected with the corresponding professors. So it could be jointly defined, co-defined problem, so that the problem definition makes sense from the research perspective, professor's perspective, as well as industry perspective. Then we can make things work actually. Again, the trouble is that this can happen if we have indigenous infrastructure, indigenous R&D setup actually. We cannot expect this much from the international multinationals actually. BTech, MTech projects are allowed to be taken jointly. This is the second bullet I mentioned, with the industry collaborators. In fact, in my opinion, the problem definition has to be joint. In fact, I don't want to entertain a student to go for internship if the problem definition is not approved by the professor, and then professor continues to follow up and eventually agrees that something has been progressed actually. BTech, MTech and MSR projects, research problems may be defined jointly by the industry collaborators. So we should have industry defined problems. And then, for example, in fact, at one point I suggested Ericsson could not give us the internal details, fine, because of their IPs involved. But what Ericsson could have done is define some joint research problems which can be co-guided by Ericsson and IIT Delhi. Okay, Ericsson, I am taking name as an example, but not otherwise, not to quote actually. Okay. And encourage industry-sponsored MTech, MSR, PhD students. In fact, this is also to motivate our research to be more applied, actually. In fact, what I see, many of our communication colleagues, researchers, research output are quite away from what industry needs today, actually. They are publishing, including myself, actually. We are publishing in top journals, but these are quite far away from the implementation actually. So if these problems are jointly defined, then we can derive. I'll give you some more interesting ways that I see that is actually could be possible, and we are able to do something about that actually. So what we have been visualizing from, in fact, I was heading this. I hope it is stable. Okay. So so what we visualized is that. So we as academics are core researchers. We should have a close connection with R&D practitioners, possibly in the same unit, that center of excellence, center for excellence that I'm talking about. And also we should have technology users. We should have right access, ready access to them. For example, let's say a lot of strategic problems. Strategic problems, unfortunately, have to be solved by internal R&D only if we want to solve it truly, because these strategic details cannot be exposed to the multinationals, and as a result, the equipments or products that we buy from the multinationals most of the time do not serve our purpose to the full extent actually. So if these three parties can be actually co-located or have very close connection, then that could be actually promote this facility much actually. So we have been trying to develop that kind of infrastructure or ecosystem. So core researchers are regular professors, and R&D practitioners who have spent their time in the industry whole their life, maybe some major time of their career. They are invited, they understand what works for industry, how to make a product. In fact, they have specialized how to make a product what works in the field actually. We know how to develop an algorithm, and we can give a proof of concept, but if we can connect these two, it could be very useful. And so we have researchers who can think deeply. We have R&D practitioners who can actually make systems which work in field. And also if we have technology users who tell, okay, this is exactly what we are looking for, this is how it should be done. Maybe co-development can be done. These users could be actually invited time to time. We define the problem, or they define the problem for us, and we interact with them, and then eventually do things. So this is the vision that is actually interesting for us actually. So what we are looking for, more applied research, how to do that. Continually upgradable system, so collaborative product development. So what that means is that we could actually take up problems from industry which can be done jointly, which can be developed in a co-development fashion, technology incubation, and it can also facilitate startup in the process. So what I mean is that if I have this infrastructure, applied research infrastructure, this can help us in terms of product development, in terms of industry relevance of our research outcome, and also this facility can be used as a possibly test facility or test place for the service providers or the system certification agencies and so on. And also it can facilitate in terms of IPR generation. So another, in fact, these bullets, a lot of details I can explain. One of the point that I observe or I experience is that today, possibly we can easily file a patent. Patent might be granted, but what to do with the patent is the next level problem actually. So who will take the technology? So this is again a problem, because we develop the patent because this idea is bright, patent is granted, but unless industry is ready or industry is actually doing R&D, they are not taking up the patent actually. So these patents are beyond our list of patents. It does not go beyond that actually. So if I have to translate that patent to a product, then we need to have our possibly internal capability, we can actually, internal engine which can make this a product. For example, if I have the basic R&D infrastructure which can make a proof of concept prototype, and then we can possibly have our own startups, or maybe other startups can be invited, and then startup can take up from there actually. So summary, what I'm saying is that beyond our core theoretical research, if we want to make ourselves more technologically relevant, we need to have our own R&D infrastructure or other which can develop these prototypes, and we also have to invite and generate our own startups which can take up this for commercialization perspective. So as individual researcher, we can do at most lab prototype, which is not sufficient for even campus deployment. For campus deployment prototype, to be scalable, we need to invite these R&D engineers which can take up to that campus deployment or maybe field deployment. But from there, if I want to make an actual product, customization of the prototype into product requires some extra major exercise, and that is where these startup possibly could come into play actually. Again, why our startup is very much required, because we do not have actually core R&D company in communications area. Only name I can think of is Tejas Networks, which is very well known in the area of optical networks. They have a good unit in wireless. They are coming up in recent years. Sankhya Labs is another very good lab, but this is actually a very focused area of broadcast spectrum related research actually in a very specific area. But so as a result, we do not have many. So that is why we need to grow our startup culture in that way. So if there are questions in between, please raise, because the slides are quite full. So further, so as I mentioned, in the process, if I have this capability, it will naturally help our communication research infrastructure, communication systems research infrastructure. As I mentioned, our labs, communication labs are, in fact, the one observation that I have is that newer IITs, communication labs are better than older IITs. Why? Because older IITs have set up these labs 20 years ago, and it has not been upgraded to the modern level today, unfortunately. Whereas newer IITs, they are starting today, they are seeing a little bit, and they are doing possibly up to date today's lab. But again, maybe 20 years later, this also might be obsolete unless we upgrade ourselves, and that upgradation requires internal regeneration, actually. Okay, then enhance collaborative interdisciplinary research. So this is also very, very important. In fact, if we do not have our these system research facility, so you see, communications used to be a vertical by itself, right? So mobile telephony or TV or whatever actually. Today, communications is actually mobile telephony, video telephony, these are very saturated. So communication has become integrated into any engineering you can think of. Robotics, smart manufacturing, mechanical engineering, go to biomedical engineering, your remote surgery or the remote diagnosis, etc. So this means that communication has become a multidisciplinary resource. So as a result, we need to have this infrastructure, and then we can invite all these cross-disciplinary researchers and provide the communication-related features. For example, if someone is doing some drone-related experiment actually, so I want to control this drone remotely. That requires ultra-low latency capability. Ultra-low latency communication actually. Some other scenario, possibly drone is actually used for imaging purpose, maybe situational awareness. In the border area, it goes and it takes snaps, and then it tries to create the awareness about the situation, and then take instant action on that actually. So that requires not only this ultra-low latency connectivity, but also broad bandwidth because video images have to be collected at a high rate. It has to be processed on real-time basis, and there are constraint of energy, there are constraint of bandwidth. Bandwidth might be insecure also. So this is a quite deep interdisciplinary problem actually. So this systems development actually can help this multidisciplinary research. I gave some example here: smart manufacturing, autonomous vehicles, pollution monitoring. We have been doing some things: mobile edge computing, smart city, power grid, environment. So communication is actually today very cross-disciplinary. So we need to have the capability to tap that opportunity actually. Okay, so and improve the teaching methodology. In the process also our teaching can be modernized if we go by. So the visualization is that if we are able to have this communication research translation facility with the help of modern engineers, then we can create multiple. These are some examples of what all startups that we could imagine actually when we created this thing. We have been actually doing some of them already. So this is what. Coming forward, so this is what we have been doing in some sense. In our lab, we have created a 5G and beyond system, which so our visualization has been that one setup. Setup one is for deep research. I can implement these details if required. Other setup is ruggedized for, let's say, some startup wants to test some use case or do some use case research on that, or use case development, and so on actually. So very quickly. So this again slide is very loaded. So what I am trying to show here is that this initiative that we have taken, that so the other aspect I wanted to highlight is that actually when we started this initiative of 5G and beyond system development, we found that we have a good expertise, good setup expertise in the country. In fact, there are a lot of engineers who are working for multinationals in Gurgaon, in Bangalore, in Hyderabad. So the only challenge is that we have to hire them at that dollar salary or euro salary. So if we have that capability, we can tap these resources and we can do whatever we want actually. So we have got some traction in the process. So MEITI, the Ministry of Information Technology has assigned some good money after seeing that we have developed this open 5G system. They have given some fund for ruggedizing these things so that this 5G system can be taken up by different startups. So that is actually an initiative actually is paying some interesting. In fact, this is a 20 crore project between IISc and IIT Delhi. IISc is doing Open RAN project. We are doing OAI-based 5G system, 5G and beyond system. So they are interested in both of them. So we are actually collaborating. We are a team actually, and CDAC Trivandrum is also part of it actually. DRDO has funded one of our research, spectrum sharing research. In fact, I presented that we have some theoretical results. Now we have this setup and we have engineers who can actually develop, take up this for industry field demonstrable prototypes. So DRDO has given a big project on that. Teridem Corporation, this is actually so this is an example. There are other companies also. This is a hydroelectric development company actually. They are power development company in the Himalayas area. The hydroelectric power they are generating. So they got to know that we are doing these things and they are interested in setting up this 5G private network for having proper connectivity, because in those remote areas, these Airtel and Jio and Vodafone do not have any revenue benefit, so they are not going to provide the service sufficiently. So they are interested in that, and also they have given project that okay, we have been doing some developing some use cases. They are interested in testing those use cases in that infrastructure. Again, some good money, and. Okay, I think these 1 and 4 are repetition. Then so there is something is in pipeline actually. So in terms of startup development support that is coming up. So there are some multinationals who have actually got some understanding that something good is going on. So Nokia, Qualcomm, MediaTek, they have also actually funded some small money, 1 year donation money, nothing to be reported. That is good actually, because they are interested in promoting international research. And DOT recently DOT has set up this mission of 100 test beds across the country. And we have been given 25 test bed development order, our startup, actually internal startup. And Indian Navy has funded something for making 5G network in a box, and so on. So TEC has also funded something for promoting the startup and stabilizing the startup, and so on. So I think I can have a pause here. Are there any questions? Yeah. Yeah. Yes. This is the one actually. So 100 5G lab projects. So our startup has got the responsibility for developing 25 of them. And what they are interested in is that other systems are being developed from the in-house. These are called closed or in-house software, whereas we have started with these open 5G actually. So ORAN compatible. So they're interested in open 5G system. So as a result, this is about that actually. So yeah. So I think this module here is actually a tabletop version of these big rack systems. So this module. In fact, there are other diagrams. These I have not shown here. So this is a tabletop module. This is the 5G base station itself actually. So DU, CU, RU sitting there. And this is the radio unit which is radiating at the last module actually. So the first module is the power module, then DU, CU, and RU, radio unit. Yeah, I think I will. So this is an example. I think I can skip through. If there are questions, I can take up. So this is basically the application, this IoT application. So what we have done is, this is the power of this system that I discussed so far is this. Using my own capability of what is that called prototype development, we have done some IoT because we thought that does not require major investment and major engineering effort actually. So embedded engineering effort is sufficient, and the students, PhD students, master students, BTech students can be taken help of and to do these things. We have developed these things, smart metering, pollution monitoring. We have deployed in campus, and but what we are interested in. So we have also considered that our edge computing is happening on our laptop. The laptop is acting as the base station, which also acts as access point and edge compute, etc. So we wanted to actually integrate truly with the 5G system. So now that we have this facility, our in-house 5G and beyond facility, we are integrating that with some of the IoT use cases actually. Okay, the many details I will skip through. Okay, so these are. I think this I can skip through. Yeah. Skip through. Okay. Anyways. Yeah, I think I am done on this aspect. If there are any questions, fine. Otherwise, I'll move on to one of my research topics. Are there any questions from the students? Are there any questions from the students? Okay. Any questions otherwise from the professors? Okay. So what I think I'm also already a lot of time taken. Okay, so this is one of my research problems that I have been working. In fact, based on this research, we have got this project from DRDO, and also Nokia has given some global donation money. Okay, so what we are looking at, so this problem, if you are a communication student, you will have some background about what I am talking about. If not, you will be possibly a little bit off the track. But if you feel that there are some things, some keywords are striking your mind, and if you want to know more, raise hands. Okay. Otherwise, these slides are rather quite deep in terms of conceptual details. I'll go through. Okay, so why we are doing this spectrum in-band coexistence? Let's come back to the title here: in-band coexistence and spectrum shared communication. So, today what happens is these spectrums. Are there any questions? No questions? Then please keep quiet. So today, if for any wireless communication, different service providers are assigned different bands. Okay. So if, for example, let's say Hyderabad, there are how many service providers, wireless service providers in Hyderabad? Can you name some of the wireless service providers? Yes? Wireless service providers? Who is your service provider, mobile phone service provider? Airtel. Who else? Jio. And? Idea, Vodafone, right? So, let's say 3 of them, okay? So, let's say, and what is the frequency of operation? You do not know. Do you know at what frequency it radiates? Not true. Okay, so there are multiple bands actually: 900 megahertz band, 1800 megahertz band, 2300 megahertz band, and then depending on the country, these vary actually. Let us consider that this is operating in 1800 megahertz band. So 1800 megahertz band means that center frequency is somewhere around 1800 megahertz, means 1.8 gigahertz, and so it possibly has about let's say 15 megahertz bandwidth entirely available, let's say, and what the current allocation is that 5 megahertz will be given to one service provider, another 5 megahertz to another service provider, another 5 megahertz will be another service provider. Okay, so these service providers operate in their own assigned band. This band has to be purchased from our TRAI, from DOT, by paying hefty money. And then DOT currently earns money just by selling the bandwidth. Okay, you have taken these 5 megahertz band, you have to pay these many thousands, crores, and so on actually. Okay, so now this is one example. The other example is that so question here is that so these 3 bands, let's say band A, band B, band C. So band A is given to, let's say, Airtel. Airtel is not supposed to operate ever in band B and band C. Okay, so even if it happens that when Airtel requires some more resources, more bandwidth resources, and band B and band C might be not so active at that time, Airtel cannot go there and use that actually. Okay, so as a result, what happens is that the capacity of the network, capacity of the channel is rather less than what can be achieved. So one analogy that I can give here, I may have a slide here. So this is one very interesting slide. So if I imagine that this is a big bit pipe, okay, C equal to 7C on the right hand side. This is a let's say big bit pipe, And these bit pipes surface area or the area is the same as these bit pipes cross section. Okay. Now this bit pipe has is divided into these bit pipes is divided into 7 small pipes. Okay, and imagine that this wall thickness is almost 0. Okay, what that means is that net area of these bit pipe and net area of the other 2 bit pipes are actually the same. So it can be theoretically shown that the left hand side bit pipe water carrying capacity, let's say this is a water carrying bit pipes actually, water carrying let's say this is a fluid dynamics actually. So water carrying capacity of these 7 set of pipes of the same cross section is going to be much lesser compared to the bit pipe which is actually one as a whole. Does that intuition sit well with you? Yeah? So what I am saying is that if I have a big pipe, the water carrying capacity of that pipe is much higher than the same pipe divided into small pipes. Okay, imagine that the pipe, the wall thickness is close to 0, so area wise you are not losing, yet the flow capacity, water carrying capacity is much lesser. So this is an analogy with respect to what I told actually. This entire bandwidth of 15 megahertz is divided into 555. The net traffic carrying capacity is much lesser than what can be achieved if this entire capacity is given to all the service providers. Okay, so that is what is actually objective. Why? Because it has been studied that these wireless channels, however busy it is, on average the utilization of the channels is not more than 25%, 23%, 25% actually. So that means that these resources are not being utilized efficiently. There are many other details I'll not go into. So question is that we are trying to look at this spectrum shared communication. So if I have the spectrum in, let's say spectrum means that let's say 7 frequencies. The 7 frequencies are given to each of these users individually versus all of them are given these all resources, then the capacity of the cell can be much higher. We are looking at that problem. So in another context, from the my specified problem is something else right here, in-band coexistence. So in this case what we are looking at, so in the example that I gave is called spectrum sharing. The same spectrum is equally being shared by all the service providers. So how to achieve that actually? Versus the other possibility is that, so there are some bands which are actually assigned for legacy purpose. For example, fixed satellite system, digital terrestrial TV. So these bands are actually very underutilized, possibly 5% or even less of the time, and it is utilized. But because these are legacy bands, no one can go and use them actually. And our current strategy is that because this is a legacy band, this is actually provided to that agency, let's say broadcasting agency, one cannot use this band wherever there is radiation. Okay, so we need to maintain the spectral and spatial distance for operating in the same band actually. So we are looking at the strategies or possibilities of utilizing this band which is very underutilized otherwise, without going for this restriction of spatial and spectral separation. So my time is almost up. I'll take possibly 5 minutes if you allow. Is that all right? Yeah. So I'll try to wrap up. Otherwise, it will be kind of, yeah. So I'll quickly go into one motivation here actually. So you see why this is very interesting is that look at this situation. So a broadcaster is transmitting from a broadcast tower. Okay, I don't know in Hyderabad where is the broadcast tower. In Delhi there is a tower called Pitampura location. So it is radiating at a high power, and the power radiation goes as the distance increases, radiated power reaches at a much lower level, And so this dotted vertical line is the coverage distance. So now current strategy says that you are not supposed to operate up to the dotted line. So if you want to operate in the same band, you have to operate outside that actually. Now, the horizontal line is the interference threshold. What that means is that if the signal to noise ratio is above that level, then the receivers, broadcast receivers can sufficiently receive the signal. So what that means is that the broadcast receivers which are very close by the broadcast transmitter have significant interference margin or noise margin to play with actually. So if on the right hand side, what I'm saying is that if someone goes and operates in the same band coexistently and then transmits at a high power, these vertical bars here, these blue bars, it shows that this blue bar at someone can radiate in the same band at a quite high power and inside that forbidden area rather in the same spectrum, and as it goes further and further away, its transmission ability is reduced, so that interference and noise margin can be maintained actually. So summary is that my interference and noise threshold required is this height. That height can be maintained this way, that red dotted line actually. So that means that we can actually sufficiently play inside this so-called forbidden range or forbidden spatial distance, and in the same band without hurting the broadcast reception process. So that gives us a motivation that the current strategy that the agencies have been taking or have taken is very suboptimal, and it can be actually improved actually. So this is one motivation, and there are other dimensions one can play with. This is only power dimension I mentioned, which is normally in cognitive radio one talks about. We have other dimensions like temporal dimension and spectral dimension, FFT size, bandwidth, and so on actually. There are multiple dimensions one can play with. From the transmitter perspective and from the receiver perspective, one can use some advanced reception techniques, interference cancellation technique, and then that can actually operate, allow to operate in the. Okay, so there are many other details which I think I can skip through. So we did some experimental study to make a proof of concept that this can be actually workable, and these were showing that I think it shows that this if I play at the power level, what can be done, if I play at the temporal level, what can be done, and different studies, and that shows that I can transmit at a higher power but transmit at a shorter burst, temporal burst, that is effectively going to maintain the interference threshold. And so on. So the one challenge in this broadcast in-band coexistence is that broadcast receivers are typically do not communicate back. So as a result, broadcast receivers are not known. So I am interested in operating in the same band, but I do not know where the broadcast receiver is, because broadcast receiver does not generate its own signal actually. So this is the conventional digital terrestrial TV transmission or satellite transmission receivers are. But there are modern techniques from the reception perspective. These ATSC3, the advanced the broadcasting system, where these receivers also are allowed to communicate, and that can be exploited for coexistence better actually. Okay, I think so this is kind of, we did some different studies that if I only go by the statistical data, what can be done, versus if I do a geolocation based approach to identify where the potential receivers are, what can be done, and so on actually. Okay, so so the same problem has a different dimension when I look into from the satellite receiver perspective. So terrestrial receiver perspective and satellite receiver perspective are very different. So I wanted to point out that actually. Okay, so I think I'll close here. Maybe if there are questions, 1 or 2 questions I can take up. Okay, this is for the satellite systems, and yeah, I think I'll close here because time is already up. If there are any questions, any questions? One question. Okay, okay, thank you.
Hello. Ladies and gentlemen, esteemed guests and participants, we now move into the validity ceremony of our event. It has been an enriching experience filled with learning and collaborations. We are here to celebrate our achievements and acknowledge the hard work of everyone involved. Now, at this moment, I would like to invite our distinguished guests to the dais to share their insights and reflection on our event. Now I call upon Mr. S.I. Prashant Garu onto the dais, please. Now I call upon Dr. J. Krishna Chaitanya Garu, Dean R&D, Vardhaman College of Engineering, Hyderabad, onto the dais. Continuing, I would like to call upon Dr. S. Rajendra Garu, Dean Academics, Vardhaman College of Engineering, Hyderabad. Now, I would like to call upon Dr. Y. Vijayalata Garu, Professor of CSC, Dean Student Affairs, Vardhaman College. Now, I would like to call upon Dr. M. A. Jabbar Garu, Head CSM, Vardhaman College. Extending now, I would like to call upon Professor J.V.R. Ravindra Garu, Professor and Principal, Vardhaman College of Engineering, Hyderabad. Now I'd like to call upon Professor Swadesh D, Professor of Electrical Engineering, IIT Delhi. Onto the dais, please. Thank you, everyone. Now, I would like to call upon Dr. J.V.R. Ravindra Garu to address the participants.
Respected dignitaries on the dais and dear students. I don't say this is a hectic 3 days, but I personally feel that you learned something. On top of it, at least, the path. That's very important because the guidance is the most important in the student career. At least, by this time you should have understood that what actually you're supposed to do or which component in your career makes a major role or any kind of the research that you could decide after this 3 days of summit, that would be good. But apart from that, though we made it many technical components in this particular summit, a couple of leadership talks also we have introduced, and one talk yesterday you have seen on the innovation also. So that's going to be the major role in the student career. So don't stop thinking, and then You have to move ahead, and then you just have to nurture your own career. Thank you very much, and good luck. Safe travel.
Thank you, sir. Now I would like to call upon Professor Y. Vijayalata ma'am.
Good evening, everyone. Distinguished guests on the dais, off the dais, and dear delegates. I hope the 3 days stay at Vardhaman was memorable and excellent. Hope you agree for that. So this has set a mark where we have seen many conferences and student summits. In my experience, we have seen like art and congresses and section student congresses and all India student congresses. And this have set a benchmark like an international standard where we have invited many delegates across the country with variant their own disciplines and also the collaboration of the societies who have come forward. I think this would have this is really a wonderful platform for everyone to exchange their ideas, knowledge, and connect. Networking. What yesterday we have heard about from one of the speakers, conversation. How do you communicate with the people? This is very much needed. I hope on behalf of IEEE Hyderabad section and IEEE India Council, I wholeheartedly thank the Vardhaman College faculty as well as management for hosting this International Leadership Summit. And thank you for giving this opportunity. Thank you very much.
Thank you, ma'am. Now I would like to call upon Jabbar sir to share a few words.
Okay, thank you. Respected dignitaries on the dais. Of the dais, Professor Atunlegi sir, deans and heads of Vardhaman College of Engineering, and also the participants. The 3 days, the event, which you have gone through is a wonderful event, which is a combination of various events, I can say, starting from the technical aspects, workshops, and also yesterday you have seen, almost I think 5:30 or 5:45 to night 9:45. So apart from your regular academics, you have enjoyed a lot with these events. You can take away, whatever you have learned on these 3 days, and you can interact with your fellow colleagues. You can interact them, and you can, disseminate the information about the importance of IEEE and also IEEE membership. If you take the IEEE membership, what are the advantages, how you have participated in various events. On behalf of IEEE Vardhaman Student Batch, I congratulate the entire team for meticulously planning this event and making it as a grand success. I also thank the SAC team. Yesterday we have seen the wonderful performances, the students and also the SAC team behind the conducting various events. And also congratulate the entire volunteers, behind the screen. If you take the movie, you will see only the hero, heroine, but there are a lot more people behind, successful of the movie. There are so many volunteers who work day and night to make this event happen. So I hope you enjoyed this 3 days event at Vardhaman. God bless you.
Thank you, sir. Now I would like to call upon Dr. S. Rajendra Garu onto the dais, please.
Dignitaries, esteemed guests, delegates, deans, heads, and all. Very good evening. As we come to the close of this IEEE Education Leadership Summit 2024, I should take a moment to focus on what were the learnings that were happened in the last three days. Almost 50 speakers have come
on a single platform. It is a very great thing that we get out of these such type of events. Different experts from all the advanced technologies covering IoT, UX, UI design, then DevOps, AI/ML applications, solar technology, so many other, all diverse fields have been covered. And all these 50 speakers have well stated all the diverse needs of the delegates. Almost 600 plus delegates have attended this program, covering around 50 institutions all over India. And this is a huge event where the knowledge sharing has happened. And we all have gathered here on a particular passion. Like we are here to for the advancement of education in engineering and technology. With that passion, we have gathered here, and all the learnings that you got from the experts who have presented here in the form of keynote sessions and in the form of workshops. You might have gained the knowledge. This is not just over. You have to take it forward to your institutions, share the same knowledge to your friends and colleagues, so that in the process of change making, like change and transformation should happen in the engineering education, which leads to the practical exposure, so that all the students should meet the requirements of the industry. I hope that this event has fulfilled that passion, and you will be succeeding in your future. So with these words, I would like to thank all the organizers for giving this opportunity, and thank you all.
Thank you, sir. Now I would like to invite our chief guest of the session, Professor Swadeshi D, IIT Delhi professor, to address the gathering.
So I'd like to thank again the organizers for inviting me. This is my second time I am here. So as I was trying to motivate the students, actually one aspect that I felt as co-researcher, that we need to think of we need to think beyond doing only research. And that is only possible when the students also come forward and participate, which actually I did not explain, or I did not have time to explain possibly. Our current problem is that the students are chasing job as if getting job is the target of life, which is actually not true, not correct actually. Rather, I would say that if you chase your learning, actually job will chase you. This is, I'm not exaggerating actually. So try to follow your passion, whatever subject you think that is actually motivating you, whatever area, I'm fine. So I'm not saying at this time a ECE student cannot go to, let's say, geography, of course. But within ECE, there are a lot of dimensions. You can actually go to some avenue which actually motivates you. Take up that and learn with passion. Take the classes, attend the classes, and chase yourself. That will actually take you forward. And getting job is not objective of life. Because after 2, 3, 4 years, when you make a lot of money, then what you feel that what next? Your life is 40 years, 50 years ahead, you have to think of, right? 20 years later, what you want to be, you should think actually that. So I think if you can tune yourself in that direction, that will be a great achievement for such workshops actually. So thank you again for participating.
Thank you so much, sir. Yeah, every event starts and every event has to come to an end. So we'll start with the contest, whatever we have been held so far. The global hack. We did this in the 2 phases. Phase 1 was hosted in the same institute on 14th of August, where we have been shortlisted some of the teams. Phase 2, the global hack, the cash prize of $500. So, we are ready? Okay. So, I request Dr. J.V. Ravindra sir, Sadesh sir to kindly come forward, along with Vijayalata ma'am also. So this is the IEEE R10 EA funded contest, the global hack. Let me give it to the first prize. The first prize and the $500 cash prize goes to Project Mera, The caring champion by Nikita Agra. Congratulations. I request all the members from the team kindly come forward. And the second prize goes to Rescue X. Rescue X. Heartily congratulations. Sir, cash prize, they'll directly credit it to their account, sir. What is the, which college you're from? Yeah. The team is from Vidyashilp. Huge round of applause. 2 phases. Around 80 teams participated in the global hack across India. Team 2. Yeah, please come forward. Rescue X by Premjit. You're from which college? Yeah. Rescue X by Premjit, KPRIT, Coimbatore. Huge round of applause. Huh? Next, we have the other contest that has been happened. That is the Code 0, which was the online coding contest in parallel to the IEEE Extreme, where that is going to happen soon. So we have the first prize. We are very much fortunate to have Nia Akila from Vardhaman College of Engineering. First prize, IT. First prize, Nia Akila. I request Dean Rajendra sir to kindly collect the award on behalf of the student. Yeah. Next, second prize, Salih Azim, KPRIT, Coimbatore. Third prize, Anshal Gupta from Vidyashilp University. Hearty congratulations. Third prize, yeah, is there. Next. Moving forward, we have done the IEEE section SB chapter presentation. I request even Dr. M. A. Jabbar sir also to kindly join with them. We have got around 10 presentations. Among them, the jury has finalized the first prize goes to Sri Sai Ram Engineering College, Chennai, Madras section. I request the team to kindly come forward. And second prize goes to Vidyashilp University. Yeah. I request the complete team to kindly come forward. Next, moving again. For this event, we had several ambassadors. So among them, we wanted to recognize the best ambassadors. One is Ritesh Gutedar from Pune section. Ritesh, kindly come forward. Second, We have V. Sai Chandana Reddy. V. Sai Chandana Reddy. Third, Kavya Shri R.D. 4, Somu Sudarshanam. Darshini. Sanjana. K.M. Vasudev. Balanivas. Swati CP. And Arish. Kindly come forward. Please make it fast. Yeah. Thank you so much. Now, I would like to invite Javier sir to kindly felicitate Swadesh sir. Sayed, next ma'am, Vijayalata madam next. I request the dignitaries to kindly felicitate Dr. Y. Vijayalata ma'am, the chair of IEEE Hyderabad section. Make it fast. Next, Jabbar sir. Jabbar sir. Next, we would like to request to felicitate Dr. Hemay Jabbar sir, Secretary IEEE Hyderabad section. Next, fast. Last. Thank you so much. We are coming to the end of the valedictory program. As the chair of IEEE Education Study YP Ad Hoc Committee and the organizing chair of IEEE Education Leadership Summit, I extend my heartfelt thanks to all the dignitaries, all the guest speakers, all the workshop speakers, all the colleges who have supported for this event to make it possible. This was a one-year journey where we started last year and we are still continuing, and we hope you all participants have been enjoyed. Where the statistics says we have around 700 plus delegates, we have around 10 plus ambassadors, we have around 50 plus volunteers, we have around 100 plus organizing committee, we have around 50 plus speakers, and we have around almost around 1,000 plus members part of this IEEE Education Leadership Summit 2024. It was a great huge support of the host college, Vardhaman College of Engineering. We are very much happy and proud as an alumni of Vardhaman College of Engineering. We were able to make each and everything possible, whatever have been planned. The workshops, the sessions, the speakers, this platform has created a unique way where we are able to create an international brand. And we were able to thank all our sponsors, right from the Host Institute, Vardhaman College of Engineering, IEEE Vardhaman Student Branch, Diamond sponsors, IEEE Education Society, IEEE ComSog, Gold sponsors, IEEE Students, OM, Silver sponsors, DIES, Signal Processing, Electronic Packaging Society, MTT, Bronze sponsors, Procom, Cube, JCube, Horizon Spectra, Technical co-sponsorship, IEEE Region 10, IEEE India Council, IEEE Hyderabad section. Workshop partners, pre-university programs of ComSoc educational programs. Tutorial sponsors, IEEE CAS and IEEE Art and EA. Promotional partners, IEEE Foundations, VTS, IEEE Collaboratech, IEEE Puzzlers, IEEE.TV. On an outside, I would like to thank each and everyone who have been supported directly or indirectly, starting from our management of the Vardhaman College of Engineering, Dr. T. Vijendra Reddy sir, Prabhakar Reddy sir, Upendra Reddy sir, and Rashakar Reddy sir. And also our finance committee, I would like to place on record the support from the finance committee, Anwan Reddy sir, Raghu sir, as well as Vinay Reddy sir. And offset, I would like to thank to all the Execom of IEEE Hyderabad section, IEEE India Council, and IEEE Region 10, and staff at the IEEE MGA and IEEE Education Society. And I would like to thank all the heads, deans of Vardhaman College of Engineering kindly supporting us, starting from the Department of CSC, ECE, EEE, IT, CSD, AIML, AIDS, Mechanical, Civil, and MBA, to all the HODs, a huge round of support from all the departments, a huge round of applause to all the departments. And an offset, I would like to thank all the speakers who have come all the way from all the different 7 countries, and even some of the speakers have gathered even in the online platform. And on an offset, I would like to thank all the IEEE Education Society YP ad hoc committee members who have been part of this program. Thank you so much. And finally, I would like to thank the Execom members of the IEEE Hyderabad section, Dr. Y. Vijayartha ma'am, Jabbar sir, Mosmi ma'am, and Jay Prakashan sir for giving the collaboration support from the IEEE Hyderabad section. And I would also like to thank the presence of Dr. Atul Negi sir, who has been part of the program. Thank you so much, sir. And finally, not the least, the people who are behind this screen, who have supported us in organizing this IEEE Education Leadership Summit in a very huge way. Whatever we have been asked, everything was approved within no time. I would like to place on record and thank from my bottom of my heart, being the alumnus of the college, I would like to thank Dr. J. Krishna Chaitanya sir, who was background support for all the organizing thing. Thank you so much, sir, for all the support, whatever you have been given. And to all the organizing committee, Varma sir, Anand sir, Manoj sir, and all the team who have been able to guide us from the bottom of the work, whatever we need. And sir, sorry is a small thing for me to tell you, but Dr. Javier sir, this is a great platform that you have given to me to host this event in Vardhaman College. And from all our committee, I would like to thank you. With this, I would like to tell on behalf of all the students over here, a big standing ovation to you, sir. Big standing ovation to you, because this could not be possible without your support. All this could be done only from you, sir. Huge round of applause. Whatever we have been asked, each and everything. Some things were not even permitted in the college. If you take fire camp or anything, whatever we enjoyed. But sir made it possible, being the general chair. He made it saying, yes, sir, really, thank you so much, sir. And finally, I would like to thank all the participants. Everyone, thank you so much. With this, we are concluding the IEEE Education Leadership Summit 2024. Yes, the event is over, but what's next? That is the question. So I hand over the mic to Dr. J.V. Ravindra sir to reveal the next upcoming decision, whatever we have been taken.
Mobile phones not allowed, that's okay, right? That's not under my purview, right? So, yes. Slide, please. That's the next one that we are organizing. So, Robotics and Automation Society, that, we got the approval $25,000 that, we are going to plan next year, 2025. So, that's going to be the next huge event that's going to happen at Vardhaman College of Engineering. So there will be another official launch, and we will invite all the students as well as the other people to this event. But there is a time, but we just would like to announce our next event. Thank you very much.
Yeah, I request everyone to kindly rise for the national anthem.
जनगण मन अधिनायक जय हे भारत भाग्य विधाता पंजाब सिंध गुजरात मराठा द्राविड उत्कल गंगा विंध्य हिमाचल यमुना गंगा उच्चल जलधि तरंगा तव शुभ नामे जागे तव शुभ आशीष मांगे गाहे तव जय गाथा जन गण मंगलदायक जय हे भारत भाग्य विधाता जय हे जय हे जय हे जय 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 हे
Yeah. Dear participants, the buses will start at 4:30. So please go and board your buses. Please have your snacks arranged outside. I request all the deans, everyone to kindly stay back. We have the felicitations. I request all the deans to kindly stay back. Participants can leave. So I request Dr. J.V. Ravindra sir to kindly felicitate Dr. J. Krishna Chaitanya sir. JKC sir. ఆగండి సార్ ఒక్క నిమిషం సార్ బాగాలేకపోతే సార్ అందుకే ఆపేసిన ఫాస్ట్ రాజేష్ కొంచెం ఆగండి అయిపోయింది
చెప్పిన మాట బాగుండదు సార్ సారీ
నెక్స్ట్ రాజేంద్ర సార్ దీపక్ Yeah, we'll give you for our Deepak. Deepak, next, Dr. S. Rajendra sir. I request Venkatram Reddy sir to kindly come forward. Venkatram Reddy sir. Next, Srinivas sir, Sukanya ma'am, HVR sir, Gosbek sir, Verma sir, Naresh sir, certificate address, just that type of moment. Naresh sir. Next, andar chaleemo. I request even our civil lecturer to kindly come forward. Aite sir. Sir? Sir ekkada? I even request Dr. Atul Negi sir to kindly come forward. Atul sir, please come forward. Yeah, Atul sir, please. Outside Vardhaman participants, don't worry, your buses will be going at 5:30 as we told you. But Vardhaman participants, kindly leave the auditorium. Your buses are moving right now. Next. This outside Vardhaman. Outside Vardhaman. Naresh sir. I request all the IT team to kindly come forward. Chari sir, Dilip sir, Shoredi sir, all the IT team to kindly come forward. Sony. Thank you so much, sir, for all the support you have been given to the IT team. Shravan, sir. Verma, sir. Not here. Srinivas, sir. Hasif, sir. Kulkarni, sir. Now we'll be recognizing the IEEE YP team. I request everyone to kindly come forward. All the YP team members, Yashwant, Siddesh, Uttej. Sony, Rajesh, Sunil. I request all the YP team to kindly come forward. All the YP team. Vaibhav, Deepak, Midun, Rajpal. Rajpal. Sanjana. All the YP team. Thank you so much for all the support you have been done on ground as well as off the ground. All the Vardhaman volunteers, Rishikesh, Trisha, everyone, all the Vardhaman volunteers, even the camera team, Aniket. The team from IEEE HK and Vardhaman student branch. Thank you so much for all your support. All the workshop certificates will be handed over off the stage. Varma, yeah. Varma, sir. Did we miss anyone else? Have we missed anyone else? No, right? Okay, now we'll be giving you the workshop certificates. You please collect from our volunteers. With this, thank you.
I request the dignitaries, please felicitate Mr. M. Sai Prashant. Please get the things, please. Sai Prashant, kit this. Momento. Yes, please. All the attendees, please give a big round of applause to this guy. So he is the organizing member. No, Sai, it's mandatory. No.
అయిపోయిందా? Do you want to have a group photo? Yeah, come first. We'll have a group photo here.
Yeah, everyone, come over here. We'll have a group photo and we'll close. Yeah. I request all the organizing faculty members, everyone, HODs, deans, Atul sir, Swadesh sir, and all the organizing members kindly come forward. We'll have a group photo and we'll end the complete ceremony.
बस है अभी है अभी है